Hello friends, it's Freedom, Insight, Necessity, and today I've got another Factorio video for you. Our topic is going to be about optimizing Promethium science because there's been some changes to it in 2.1 that make everything a little bit more interesting. Let's start with some background first. So what actually makes a Promethium science ship good? Well, we could say something like, it's a ship that maximizes the amount of science made in a set amount of time. Duh, right? But what does that actually mean specifically? Well, with Promethium science particularly, there's 3 ingredients to worry about collecting, which are eggs, quantum processors, and chunks, and there's also the crafting of the science. 2 of the ingredients, however, aren't actually created by the ship itself. Biter eggs and quantum processors are something that we can make somewhere else entirely. Crafting is also kind of easy because the cryo chamber is capable of putting out an enormous amount of science. In the example that I showed there, it's making a whopping 744 science every second. Now, of course, you're not going to be able to get these ingredients inside of it, especially the 620 Promethium chunks, but the point I'm trying to make is that more than any other science, the single building crafting is going to produce a far higher amount of science. So it's really the last thing that you'll be worrying about. So, if we don't really have to worry about the crafting, and 2 of the 3 ingredients are not of our concern, that really just leaves the third one. So we want a ship that maximizes the amount of Promethium chunks being collected. That really means 3 things. We want to minimize the time we spend not collecting them. We want to collect the chunks fast, which means we want a ship that goes fast and that is wide so that it's collecting in a greater area. And we want to maximize the chunks per UPS, because UPS is a really big concern when you're working with Promethium, just because of how intensive asteroid collection and the turret acquisition is on your computer. So let's start by talking about what Promethium science actually looked like in 2.0, before the release of 2.1 experimental. So the first strategy that people thought of was the chunk hauler strategy. In the chunk hauler strategy, we send a ship towards the shattered planet, and it doesn't have eggs or quantum processors on it. But what it is equipped with is a giant form of storage, usually some form of belt weaving, that allows you to collect an enormous amount of chunks. Once you have a sufficient amount of chunks, your ship turns backwards, goes to Novice, and over Novice it collects eggs and quantum processors and turns them into the science packs that you're looking for. So the chunk hauler has some obvious pros and cons, right? In the pros section, we know that it's safe, that the biter eggs won't spoil because we only ship them up as needed when we're sitting right above Novice when they're super fresh. It can also get into high-density Promethium asteroid zones because it's getting closer to the shattered planet if its buffer is big enough, and that means that more and more of the chunks will be useful chunks, Promethium chunks, and less of them will be less useful chunks, so metallic oxide, carbonic, which you need some of, but a lot of them just slam into your ship and do nothing. In the cons section, we can see that this ship will waste time sitting above Novice because it's not crafting science as it travels. It needs to actually go back and waste time above Novice. And secondly, obviously the whole strategy requires this giant belt weave, and to have a giant belt weave you need to have a giant ship, and that means you're loading a lot of asteroids, you're shooting a lot of asteroids down, you're generally causing lag. So the next strategy is the egg runner strategy. The egg runner strategy says, what if I load my ship up with 2 of the 3 ingredients, the biter eggs and the quantum processors, and then as I collect the Promethium chunks, I turn them into science. That way, when I turn back to Novice, I'll have a ship loaded up with science that I can simply drop off, and instead of waiting above Novice for an extended period of time, I can simply get more eggs and quantum processors and maybe some other stuff, and just go back. So the pro to this strategy is that it doesn't have that problem of the chunk hauler where it sits above novice. This really never has to stop moving except for the time it takes to actually load with new ingredients. It also doesn't require a belt weave, which means it's going to be smaller, which means it's going to be faster, and it also means it's going to lag less. Now, the most obvious con, the reason that people started doing the belt weaving in the first place, is that it's unsafe. If you mess something up, if something unforeseen occurs, the biter eggs can and will spoil, and they will destroy your entire ship if you're not careful. It also can't go as far towards the shattered planet, meaning it can't get into those high-density Promethium chunk zones that I was talking about, because you're on a 30-minute timer. And once you go any farther than what your 30-minute timer allows, even if you've consumed all your eggs safely, now, because you don't have a buffer, you're just sitting there not doing anything, right? Which is what our third con is talking about. If you're in the zone and you don't have eggs, you are causing lag for no reason. You're not even picking up chunks. The final strategy is the hybrid strategy. The hybrid strategy says, well, what if I want the benefit of not sitting above novice, but I want to try and mitigate to the greatest degree that possibility where I could be traveling in the Promethium zone and not picking up chunks. And the way that that works is simply by putting a belt buffer on your egg runner ship. That way, when it comes back, it not only has science that it's crafted, but it's also collected a bunch of Promethium chunks after it ran out of eggs, and it means that you can even begin crafting the science again before you even reach the solar system edge on the way out, because you have this buffer of Promethium chunks. So, obviously, like I said, the pros are that it never stops moving, and that it's always picking up Promethium chunks, or at least it's picking up Promethium chunks in the Promethium zone more than the egg runner strategy. But obviously it is still unsafe, and it still requires some amount of a belt weave in order to have that buffer. It's probably not going to be quite as big, but it will add size to your ship, which is no good. Okay, now that we've talked about basically the existing strategies in 2.0, let's talk about how 2.1 has changed things. So the big feature that's relevant for changing things in 2.1 is platform-to-platform transfer. Platform-to-platform transfer allows us to transfer any one of the ingredients or the science itself, and so that has basically created a lot of discussions about what the best way to update Promethium setups would be. Okay, let's talk about how the chunk hauler strategy changes. So the chunk hauler strategy gets an improvement because it can now have at least one buffer ship sitting at the solar system edge. So in this example, we can see that our collector ship is doing a trip where it's flying out towards the shattered planet. When it decides to turn around, instead of going all the way back to novice, it would simply meet this other ship at the solar system edge, and it would transfer the chunks to the other ship, like so. Now, this other ship can now fly back to novice, and it can either transfer the chunks again to a stationary platform above novice that crafts science, or it could sit above novice and craft the science itself. Whatever the case, while that's happening, the initial original collector ship is free to turn back around and go back towards the shattered planet. So this eliminates our first con from our usual chunk hauler strategy, which is that we waste time sitting above novice. Now our actual chunk collector ship never goes towards novice, let alone does it waste time sitting above it. However, it does introduce another con, which is that it has to transfer chunks, which means it has to put chunks into the hub. I've created a mock-up of what this might look like in editor mode, and I want to stress that this is actually even better than the rates that you would get normally, because in this one I've used the minimum possible amount of spots, just 2 spots to connect up the cargo bays, and I have forsaken having an inserter that would actually be able to take something like fusion fuel out of this central hub. So that's giving us the absolute maximum of 30 possible inserters, swinging 6.5-ish times a second, and that comes out to about 200 chunks every second that we could get into the hub. Now, that's nothing for anyone that knows, right? Most belt weave ships like to store something like 200,000 chunks. Many of them store 2 million chunks. So 200,000 is actually on the smaller end. But if we look at an example with 200,000, we can see that that would take almost 17 minutes of continuous inserter swinging and transfer to actually do that handoff, which means we've traded sitting above novice for sitting at the solar system edge, which is no good. Now, even if you thought you could be really smart and that you could mitigate some of that time by preloading your cargo bays with chunks so that when it arrives, it can simply send a bunch of them, the reality is that even with 1,000 legendary cargo bays, you can only store 50k of your 200k chunks, which means you're only cutting a fourth of that time off. It's still going to take 12 or 13 minutes of sitting at the solar system edge to transfer this. Now, a lot of people, when presented with this problem, will say something like, well, what if I simply have more ships? Doesn't making more ships and therefore more hubs solve this throughput problem? So let's look into this. It's true that by having more ships, we would actually be able to solve the throughput problem to some degree. But adding more ships creates a problem that most people aren't thinking about. On the left here, I have basically a mock-up of a ship where we can see the total width of the whole thing, the whole asteroid loading zone, is represented by W plus 2x, where W is the width of my ship, and the 2 x's are the set distance to the left and right where asteroids continue to be rendered. That big red box is sort of supposed to represent something like the turret targeting zone, but it's really actually important because it represents where asteroids can actually spawn and where those asteroids can then collide with our ship and be targeted by turrets and basically cause UPS problems. Now, if you tried to solve the problem from earlier by making 10 ships that were much, much smaller, you would immediately run into this problem, where even though the width of the ship has shrunk by 10, and therefore that section of the ship that was loading asteroids has gone much smaller, the 2 x's, well, those are a set distance from the ship's sides, right? They don't actually shrink at all. They're a constant number, which means if you took this total width for the second ship and you multiplied it by 10 in the hopes to get the same Promethium asteroid throughput as you were before, well, now you can see that the actual amount of asteroids being loaded has gone up quite a bit. Now it's width plus 20x instead of width plus 2x. So in solving the problem of the hub throughput, we've basically just created another problem, which is that now we're loading in a much greater amount of asteroids. And this problem is going to crop up at multiple places. It's not just going to be at the place where you transfer the hub from the collectors. It's also going to be the ship that runs between, and it can also be the ship that's stationary over Novice, because all of these ships have to deal with Promethium chunks in the hub, which is no good. Okay, so basically what this means is that trying to do a strategy that stores all of your chunks on belts and transfers them between ships isn't really a good idea. So let's instead talk about the hybrid strategy and how it's changed with 2.1. In 2.1, now we can have 2 ships to handle different legs of the total distance that must be traveled, right? One of the ships can focus solely on being between the solar system edge and the shattered planet, while the other can do Novice to the solar system edge, just like the chunk hauler. In this situation, the one that goes between Novice and the solar system edge would come to the edge carrying eggs and quantum processors, whereas the one that goes from the solar system edge to the shattered planet, the one that actually collects the Promethium chunks, it would simply have science to transfer over each time. They would switch their contents, like so, and then they would basically each jettison off back to their respective duty. So the science ship should go back to Novice, and the other ship should again travel towards the shattered planet. When they reach their destination, the science ship would drop science down to Novice, and then it would just pick up more eggs and quantum processors to do the whole thing again. So what are the pros for this strategy? Well, the egg delivery ship can be much thinner and therefore faster than it would be if it also had to be the collection ship, right? We know that when we make a collection ship, we want it to be wide because we want it to get lots of chunks. But in this case, if it was just there to deliver eggs and quantum processors, it could be a lot more streamlined, and it could have a lot less infrastructure related to creating missiles and bullets and all that other sort of stuff. So what that means practically is that you will get eggs to the solar system edge faster than you would before. Now, there's a little something to reckon with there, because then they also have to undergo a step of transferring, which takes up some amount of seconds, but it should be that you're gaining at least a few seconds on your spoilage timer. It keeps the old pro of the other 2.1 chunk hauler, which is that the Promethium collector never actually has to leave the Promethium zone, right? But it adds this new con, which is that now we have a timing problem, right? What do I mean when I talk about this timing problem? So there's basically two ways that you can do it. If these ships are supposed to meet at the solar system edge, the egg ship can either be too early, and if it's too early, the eggs will sit and spoil and can even turn completely into biters before the science ship is back and ready to transfer. Or it can arrive too late, in which case the science ship will sit and sleep and do nothing while it waits for the egg ship to arrive. Now, it's pretty obvious that arriving too late is a lot better than arriving too early, because you'd rather have a ship idle and do nothing than have a ship explode with biter eggs and get completely destroyed. But neither of these are optimal, and so we'd like to basically minimize both of them to the highest degree. So, how do we go about timing the ships? Well, the first way is that we don't. We just send the egg runner when the Promethium ship arrives at the solar system edge. This will always work. It'll be super consistent, it'll never get out of sync, and the eggs will be as fresh as they can possibly be, because the egg ship will arrive and it will immediately be ready to transfer to the other ship. The con, like I mentioned before, is that our Promethium ship will sit and do nothing for a period of time. But let's try and do something a little more involved, right? So the next strategy that I could think of is that we could do something like a set timing. If we knew our Promethium ship and we said, usually it runs in cycles of about 50 minutes, right? It goes out to the shattered planet, it comes back, it's about 50 minutes. And we also knew how long our egg ship takes to load and then get to the solar system edge, we would simply start some global 50-minute timer that begins when the Promethium ship dispatches, and then we would dispatch the egg ship when whatever the total time of that timer had 8 minutes left on it, right? So this is going to be really quite simple, but the con is that it's completely inflexible. And what I mean by flexibility is that anyone who's used Promethium ships enough knows that there's some RNG involved in the way that chunks are collected. And so that usually you don't run your ship on cycles of exact amount of times, you choose to turn back around when a certain amount of eggs have been consumed, for instance, right? So in that case, this time will vary, you will get out of sync with the timer, and if things go really catastrophically wrong, you could even dispatch your egg ship before it was ready, before the collector was ready to arrive back, and get in a situation where your eggs are sitting there, they're losing spoilage time, and maybe they're even turning into biters. So it would be better to do something a little more complicated, which is what the distance calculation does. We can't actually measure distance directly from one destination to another with the space platform, but we can get speed out of a space platform, and speed is all we really need to get distance, because if we just continuously sum whatever the current speed being outputted by the space platform is every tick, it will give us the distance that we've traveled times 60, right? Because the speed is in some amount of kilometers per second, but we'd be adding it 60 times a second because that's when the ticks happen. Now, when the ship reverses direction, we could simply take that accumulated distance that we've built up, and now we would subtract our speed from it, and we would go the opposite way. Our distance from the solar system edge would start shrinking. And then it would be as simple as saying, when the distance remaining divided by the current speed, which gives us the time until we reach our destination, the solar system edge, when that time is less than or equal the time it takes for the egg ship to load up and reach the solar system edge, we would dispatch it with the universal radar. So I've actually made a mock-up ship that I'm going to show you now that does exactly that. So here it is. Right now, time is paused, and it basically works exactly like I said. This decider combinator is under particular conditions that make sure we're actually traveling between these 2 points. It's continuously summing the speeds that it gets, and this is basically this decider combinator combined with this arithmetic combinator is deciding whether or not the signal should be adding or subtracting to the distance, right? So when we're headed out towards the shattered planet, we should be adding. When we've turned around and we're heading back towards the solar system edge, we should be subtracting, right? And that's what this -1 here means. So this distance that's being accumulated, like I said, it's 60 times greater than what we actually want it to be. So we divide by 60 and we get this number. So right now we can see that this thing thinks that we are 175,655 kilometers away. And we can look over here on the right side of the screen to see our actual amount, and we can see that we're about, maybe 400 or 500, about 400 off. Right? Which might sound like it's a lot, but when you keep in mind that we're traveling at over 400 kilometers a second, it basically means that we are less than a second off with our calculation, which is really good. So then we do this next step, like I said, where we divide our distance by our current speed, and we output that as basically our seconds from our destination. And this final combinator basically just says, again, under set conditions, when we're returning to the solar system edge, when this second counter gets below the amount of seconds that I've determined it takes for my egg ship to load and reach the solar system edge, so this number is arbitrary, you'll have to measure it yourself, I can dispatch it by sending a signal through this radar. And then on my egg ship, which doesn't actually load, but that doesn't matter, right? Because it's always going to be a consistent time. When it receives this star signal, it will head on over to the solar system edge, right? So just to demonstrate the accuracy of this thing, I'm going to start this, and I'm going to show you that currently it's ticking up and it's trying to get to 400, right? And it's going up because we're heading towards the shattered planet. And this is actually slated to turn around when we reach 400. So let's try and watch and see exactly how accurate it is. When this is close to 400, that's when we should switch, right? So we get to 399 and we switch, right? So like I said, 1 second off. But now something interesting happened that you might have seen there. We were just at 398, 399, and now suddenly we're at 379. And I promise there was no cut in the video or anything. The reason that this is happening is because this calculation of the amount of seconds until we reach our destination is based on the speed that we're currently moving at. And when we switch directions, we get a 20 kilometer a second boost in speed. We go from going 465 kilometers a second to 485, and that's just representative of the gravitational pull of the locations in space, right? Now, why the solar system edge has a gravitational pull if there's no planet there, I don't know, I'm not a scientist, it doesn't matter, right? All that we know is that this second counter adapted immediately to our change in speed to give us a better idea of when we'll arrive. So now, we can speed this up a little bit, we're just waiting for this second counter to get below 310, right? And when it does so, which it's very close to doing right now, we're going to see that the egg ship will go from being stopped at novice to suddenly being dispatched. So let's watch that in real time. We're stopped at novice, a couple seconds pass, and now we're dispatched, right? So now the egg ship is trying to fly to the solar system edge. And the thing that we're hoping for is that they're going to arrive very, very close to each other in time, right? That would be the best for us. And we also know that if we had to err in any direction, we would rather err in the direction that this ship that we're currently hovered over would get back first, and then the egg runner would get back a second or so later, right? So we're going to, again, watch that thing that we did to watch when the egg runner was dispatched, and that's going to show us exactly how accurate this is. So I'm going to let this get close. We're at 97, 98, 99, And if I come out of this pause and I look at the map, we're going to see that this will arrive back at the solar system edge, and super quickly after, our egg ship will also arrive there. So if I look, boom, edge, boom, the other one's at the edge, right? That was less than a second. So even this sort of rudimentary circuit that I just made in a couple hours is already this accurate, right? And can do this timing really, really well. So I truly think that this is the best possible way that we're going to be able to go forward with timing stuff. Thanks for watching the video. Hope you liked it. And tell me your thoughts in the comments.